And with that, I'm excited to introduce Mr. Ben Balls. He's the Vice President of Products at Pivot3. Are you there, Ben?
I'm here. Glad to be here today.
Thanks for being on. Take it away.
Okay. Great. Thanks, everybody, and good to be here to walk you through the Pivot3 product and technology. I'm Ben Bowles. I run the product management team here at Pivot3, so I look after all the current and future products and what we have going on, and so we'll get straight to it. Wanted to dive into what we're doing here at Pivot3 and some of the things that we're seeing in the industry and as it relates to hyperconvergence. And so, one of the things to keep in mind and set the stage here as it relates to kind of how IT delivery is transformed and being changed as we go. And so, you're all familiar with that traditional IT infrastructure, that we've been utilizing here for a number of years. And Hyperconverged has come onto the scene where we're able to consolidate and combine all the different functions into a node-based architecture. And really what that means for customers is that they can improve their operational efficiency. They can be more agile, more flexible. And to date, Hyperconverged has really been good at targeted application workloads is kind of what we've seen. So deploying hyperconverged systems for applications like virtual desktops or point applications has been very popular, and we've seen a lot of customers have success with that. We are seeing a transition occur where the customers are asking us to do more with hyperconverged, and so instead of where they've in the past run individual applications or virtual desktop infrastructure on a hyperconverged system, now it's moving more towards, hey, I want to run large portions of my infrastructure, multiple mixed application workloads, and so wanting to do more with hyperconverged. And so at Pivot3, we've been focused on delivering products that are able to not only perform underneath that that added mixed application workload type of an environment, but also provide you with the tools so that you can manage that and be able to prioritize workloads and manage the performance as you're consolidating more and more onto a hyperconverged infrastructure. And so a few of the different areas that we'll touch on here in this presentation. One will be around performance and what we're doing with NVMe architecture and our hyperconverged data path, as well as the ability to manage that performance through policy-based quality of service. Another area that we excel out here at Pivot3 is around scalability. And so we have some of the largest installations of hyperconverged infrastructure out there, and a lot of that has to do with our technology as it relates to being able to predictably and linearly scale, both the storage and the compute, and in different dimensions there. And then, finally, I'll touch on the efficiency of the system, and so being able to deliver not only the performance and the scalability, but also do it in a way that is efficient for capacity, utilizing a erasure coding technology that we've developed. And so that's what we have to cover here. The first thing that I'll touch on is something that we've worked on for quite a while and is really an underpinning for what we're doing here, and that has to do with our policy-based management and our quality of service. And so integrated directly into the Pivot3 system is a sophisticated quality of service management framework. It has multiple things that we're doing here. It goes a lot farther beyond just simply setting caps on your IOPS and your throughput. We have policy-based management, which makes things very simple to be able to apply the performance targets to individual virtual machines and volumes, and do that across the board. You set up a policy and then you apply it across all your different data sets there. We have a prioritization engine built in, which allows the customer to tell us what's their most important applications and virtual machines. And so we have service levels built in for mission critical, business critical, and non-critical SLAs. And then the system can make decisions based on that to provide more performance for your mission critical workloads and prevent things like noisy neighbor of a non-critical workload having a negative impact. Another thing that we do that's different than most is around data placement being tied to the quality of service. So, here the idea is that your most important data is going to reside in the highest tiers for performance. Your least performance sensitive data would have a tendency to live in the lower tiers. And then finally, we have our data protection services are wrapped around the policy-based management. So, things like snapshots and scheduling and retention policies are all managed through our quality of service engine and our policy-based management. A good example here of what we have of, what does it mean to have consistent performance in a hyperconverged environment. So one of the things that happens when you hyperconverge is that you're combining all the compute and the storage processing into a individual node. And so, one of the things that can happen is that without quality of service, the wrong application can get performance. You might have a performance spike in a development environment, and that has an impact on your mission critical order database. And so with Pivot3's QoS, because you tell us what the importance is of the applications and categorize them into mission critical, business critical, and non-critical, then we can do things with our software and managing the data path so that we can automatically throttle a non-critical, prevent that noisy neighbor type of a situation to ensure that we continue to deliver on the mission critical and business critical performance. Likewise, if it turns out that we need to deliver more performance for that mission critical application, the system has the ability to throttle back the lower priority virtual machines to provide that performance level for mission critical. And so these are a couple examples of how our quality of service management through policies allows a customer to hyperconverge with confidence those multiple mixed workload applications when they move those applications over to a Pivot3 system. And I'll walk through this in a live demo here later and show you how, through policy management, we can affect the performance priority in real time and show you how that affects the I/O and the latency that's delivered. The management of this is all, very simple. It's, done through a vCenter plugin. And here, it's on the screen, you see an example of, when we're provisioning a new volume, we're going to assign a performance policy as well as a protection policy. And that's really all that, the customer needs to do. They can come in here and modify these policies on the fly. If they change a performance policy, then that happens in real time. They can change a protection policy, and a lot of those are associated with, scheduling of data protection tasks, and so that would get picked up on the next firing of that schedule. We also have some pretty interesting automation built into the system. So one example of those you see on the screen, which is where I can set up a performance policy change, where on a schedule I could modify the performance policy of a virtual machine and move it from lower policy to a higher policy to give it more performance, and then back it off when we're done. And so a couple examples there that we've seen customers utilize are, perhaps you need to give more performance to an application throughout the workday, and then you can back it off at night. or you might have a periodic type of an application where the finance team needs more performance at the end of the month to process month close, and so you allocate more performance for them. And you can do that through a schedule right within our system, and so that's something that we've built in based on a fair amount of experience and feedback from customers where they have access to be able to change these things through APIs and CLIs, but this is something automation that we built right into the user interface, and it's a pretty interesting and powerful thing that they're able to do there. So shifting gears and talking a little bit about the performance of the system and what we've architected around our Hyperconverged data path. And so at Pivot3, we have a multi-tier architecture, and I'll describe that in more detail as we go. And when you compare that to what we would characterize as a single-tier architecture, this is really where the industry's been for a while around utilizing SSDs within the system, placing those behind a SAS SATA RAID controller, and then managing that all through a single node type of a environment. And so what we've done here at Pivot3 is really taken to the next level when it comes to how we're implementing a high performance data path for Hyperconverged. And so what you see there on the right is how our system is architected in that multi-tier, where we have on the front end of the system, we utilize memory as well as NVMe PCIe flash, and those are the different caches and tiers within the system. And then on the back end, we utilize SSDs or HDDs for the capacity. So the whole idea here is, as I mentioned before, with that quality of service management, we have the intelligence in our software to be able to know what data is prioritized and should reside on the higher performing tiers versus the lower performing tiers. And that's all integrated in with our data path. So the net is with a Pivot3 system, you'll be able to specify your mission critical and your business critical workloads will have a tendency to reside in the NVMe tiers, whereas your lower priority, your non-critical type applications would have a tendency to live in the lower performing tiers. We also have the data path intelligence to be able to specify different ways that we store the data to achieve different performance attributes. So as an example there, the data that's in NVMe will be mirrored on ingest so that we have data persisted and highly available. And then when we destage data out of the NVMe tier down to the hard drives or the SSDs, the capacity tier, that's when we encode the data with erasure coding. And so it has a nice balance of being very highly performant on the front end, as well as capacity efficient on the back end. And so that's some of what we're doing around our multi-tier architecture. On the efficiency side, this is where our erasure coding technology comes in. And so in a scale out environment, which is what we have here at Pivot3, a lot of the approaches to date have been to replicate data across multiple nodes to provide for reliability and availability. And so from the get-go with our technology, we developed a highly efficient erasure coding for capacity, but we also have done a lot of work around the performance of this technology. So we're on our 8th generation of our erasure coding technology. So it's not only very efficient, but it's also performs quite well. And so we can sustain multiple failures within the environment and still be available. As a customer, you can tune the different the different erasure coding levels, and to increase or decrease the amount of erasure coding that is being stored on the system, thereby affecting the level of resiliency that the system's able to deliver. On the right chart there, you see some comparisons of as the Pivot3 system scales, we have more and more nodes, we have more and more drives to spread the data across, and so therefore our system has a property of the larger it gets, the more efficient it gets, because we can spread that data and that erasure coding across more devices within the system. Whereas the light blue line and the gray line is where people have typically been with scale-out systems, where you're either utilizing two-way or three-way replication to protect the data and to achieve those levels of availability. And so that's how we are able to not only deliver the NVMe performance on the front end, but also the efficiency on the back end. From a feature set and what we offer here at Pivot3, so it's our approach is with our software is to have a all-inclusive feature set. The architecture that we have around multi-tier and NVMe to deliver that. And so on the left there, you see all the different features and functions that we have as it relates to the policy-based management and the quality of service. And so performance and data protection QoS, the scheduling, the retention policies, the performance metrics, all built in within the system. From an architecture perspective, as I mentioned before, we've built a multi-tier architecture around NVMe PCI Flash. We do the scale-out storage. We are able to leverage all of the caches within the system. We call that global cache, and so it's a very dynamic and pooled architecture that we have. And then something that we can do that is pretty unique in that we're able to integrate our hyperconverged into existing infrastructure pretty easily. And so we can pull in external storage and present that to our hyperconverged nodes. We also can present out our data storage as iSCSI connected volumes, so that hosts that already exist within the infrastructure can access our volumes and the capabilities that we have. And then from a data services perspective, I mentioned the erasure coding technology that's built in. We also have things like snapshotting and cloning and application integration, data reduction, and then provisioning is all built in. And then we've done a number of integrations with vSphere and ESX to provide the best performance and availability. And then finally, the system comes with proactive monitoring and phone home, so a comprehensive set of monitoring and support is available with the Pivot3 systems. The lineup of nodes that we have, so the latest products that we've released, they're called the X5 Hyperconverged nodes. They run our latest software, which is called Acuity. Acuity includes all the features and functions that I just described here. And then there's different types of nodes, and so depending on the requirements for the infrastructure and what the customer's looking at from a performance and a capacity standpoint, they can scale the system in different dimensions. So we have the X5 6500 and 6000 are all flash nodes. The 2500 and 2000 are hybrid nodes. And then within those families, we have this designation of, is it an accelerator node or a standard node? And so an accelerator node means that we have an NVMe PCI Flash adapter built into the system to provide for the performance acceleration. And so, depending on the customer environment and what they need, they can assemble a cluster, or what we call a virtual performance group of nodes, and manage them all from a single interface as a domain. And so you see some of the different specs and metrics listed out there for scalability of the system, the amount of compute that we're able to include in these nodes, and then selecting from the different capacity points. We also support optional GPU and PC over IP for graphics intensive workloads and virtual desktop. And then from a network infrastructure, really you're choosing between a 10 gig base T or a 10 gig SFP plus option there. And once you do that, and away you go. So hopefully that gives you a good sense of what we're doing here at Pivot3 as it relates to the NVMe data path, the performance that we can deliver with our solution. With an NVMe data path is what we're seeing from our customers is anywhere from 2 to 6 times the performance of a traditional infrastructure, and so it's delivers a lot more performance with that NVMe data path, and then providing the tools to the policy-based management to be able to manage that allows them to prioritize their applications, to confidently consolidate those multiple mixed application workloads onto the Pivot3 hyperconverged infrastructure. And so with that, I'm prepared. I'll go ahead and do a quick demonstration, and what we'll do here is I'm going to show a live demonstration of the Pivot3 vCenter interface, and specifically what we'll do is we will be looking at the performance management and the quality of service. And so what you see here is the Pivot3 vCenter plugin. And so this is a dashboard view that comes up, and so gives you a look at what we call the entire domain. So the domain would be made up of all the Pivot3 nodes in the environment, and so you can have any number of nodes, any number of volumes that are managed in that hyperconverged infrastructure. So this is all done within vCenter. And then as we drill into the different aspects here, so the virtual performance group, here provides you a little bit more information. So I have a virtual performance group here called Acuity demo, and so this is where we're running an active workload, and we're going to modify the quality of service settings and see how that gets affected in real time. On this screen, you can see different attributes around capacity and utilization, the different nodes within the environment. You see here I've got a node that has an NVMe device in it, and the health status there. And then I've got a summary performance graph here where this system is delivering north of about 240,000 IOPS is what we're getting out of the system right now. On the provisioning tab, this is where we have the storage provisioning, and so here I'm utilizing a demo environment that we're doing live demos on the VMworld show floor, both out in Vegas and Barcelona. And so I've got some data stores here called VMworld QoS, and some different performance QoS levels that we'll be modifying these on the fly. On the data services tab, here's where you see the performance QoS. So like we talked about before, I've got my policies and my service levels. This is where we have the performance targets for latency, IOPS, and throughput. So these are maximum latency targets and minimum IO and throughput targets. And then here on the right, you see the data path manipulation based on policy. So whether it's a read warm cache, read ahead cache, or a write cache, that's all managed in real time for how the data is moved across the system. We have some other capabilities around data protection, protected hosts, where we integrate with protection APIs like Windows Volume Shadow Copy and directly with vCenter APIs. And then the toolbox here, this is a real-time performance monitor. And so what we're going to do is we're going to shift the performance of this first volume and flip it with the second volume. And so right now, what you see is the top volume is running at about 32,000 IOPS. This second volume is running at about 10,000 IOPS. And so a real-time QoS demonstration that we can do is we can modify the quality of service on the individual volumes. So here I'm going to migrate this volume from policy 1 to policy 5, and then I'll do the same thing with the second volume, where I'm going to specify that it moves from policy 5 to policy 1. And so I'll modify the second volume. And so what the system is doing here is we're managing the I/O prioritization on the front end as data is flowing through NVMe. And so the software is managing how the I/Os are prioritized within the stack. And so what we should see here is a pretty dramatic change now that we've shifted that. So this is happening in real time on the system, where we've now shifted those volumes. Now this one is running at about that 9,000 level. It's in policy 5, and we moved the other one over to policy 1, and it's at that 30,000 IOPS level. So hopefully that gives you a quick overview of the capabilities that we have here with the Pivot3 products and architecture. We'll go ahead and shift over to any Q&A that's come in.
Yeah, absolutely, Bob. We do have quite a few questions that came in here for you while you were presenting. And thank you, by the way, for the very cool demo. I like how it integrates with the vSphere web client. So let me just bring up your contact info there, and I'll just leave that on the screen while we're doing our Q&A. There's Pivot3's website and an email address there you can contact for a demo or for questions. So the first question I wanted to ask you is about, just to clear up any confusion, does Pivot3 sell a hardware or software or both?
Oh, that's a good clarification. We sell our products in a number of different form factors. So we sell appliances, which would be the combination of hardware and software, and then we also have software only that we can land on specific hardware platforms that are popular with a lot of the big OEM platform vendors like Dell, Lenovo, whatnot.
Okay. And do you just support vSphere as the hypervisor today, or do you support other hypervisors?
At the moment, we're ESX only, and so that's what you've seen here today with our vCenter integration. We do have some work underway around adding Hyper-V support into the product, and so that's a roadmap item right now.
Okay, cool. Another question is, once you make a policy change in the QoS, how long does it take for you to see that change, like in the application?
Yeah, so a policy change, what we just demonstrated was a QoS policy change where we were only affecting the I/O prioritization on the front end within NVMe, and that essentially can take place immediately. As soon as we make that change, the system is automatically and changing the prioritization of I/Os as they flow through the system. Other policy changes, the data movement within the system, as well as the data protection, those can take a little bit longer to, kind of manifest and move data around or change the schedule. But it all happens within a matter of, if not seconds, a matter of minutes. So it's a pretty quick turnaround on any of those effects that would occur from a policy change.
Okay. And then another question here. John is asking, you talked a lot about NVMe. What does Pivot3 do differently or unique with NVMe than just other solutions that are out there?
Yeah, it's a good point. I mean, the thing to keep in mind about an NVMe data path is, it's a lot more than just plugging in a new device and changing some, device drivers out. I mean, to be able to take full advantage of what NVMe has to offer, ourselves included and other vendors as they adopt the technology. I mean, you really need to re-architect the I/O path to get the most benefit for performance, as well as, you're managing, flash at that point is more like memory than it ever was like a disk drive behind a RAID controller. So there's, not only performance reasons, but reliability and endurance. So we have all that software management built into the Pivot3 stack, and have been doing this for a number of years. And so it's pretty mature from being able to incorporate that NVMe tier directly into our Hyperconverged data path now.
Got it. Okay. Well, I think that's all the time we have for live questions, but a really cool demo, and there's a number of questions left for you there to answer in the queue if you don't mind sticking around.
Yeah, sounds great. I'll get to those, and I really appreciate it. Thanks, everybody.